Hello, everyone. So this is a MATHCOUNTS state question number 10. So on a state level, okay? So we have a right triangle, 5, 12, and 13 is given size. And okay, let's go with the drawing that first. So let's say this is my one leg. Okay, so near AB and BC has the common vertex. So I'm gonna go with this is B and this is A. So that's the shorter leg. And this is 12 and this is 13. And P lies on AC such that BP is bisector. Okay, so let's do that one. So we are going to have BP that will divide angle B into two equal pieces, which is a good thing because we have 45. So immediately we want to remember 45, 45, 90 triangle. And also this is a segment that divides this angle into two equal pieces, which is why this is angle bisector. Okay, and we are also given BQ, QR, RC, and those are on BC. Okay, so we are going to divide this side into three equal pieces. So this is 4, that's 4, that's 4, and that is called Q, and this is R. Okay, and let's connect those as well because we are told A, Q, and AR. And then whenever I do this, the intersection between BP, so this was P, with those two segments are called X and Y respectively. So those are X and Y, okay? This point and this point. And based on this, what is the area of the QRYX? So QRYX. Okay. So again, first of all, I want to remember the angle bisector because I see this guy is angle bisector and then it's actually dividing a lot of ratio. So to do so, I'm gonna go ahead and kind of remind real quick. So whenever you have a triangle, and then if you do have this guy segment, okay, let's call this is A, B, C, and T. So if this guy is divide angle A into two equal pieces, AT is called angle bisector. And we have a really nice relation, and that is, let me call those side. So the X, which is the side next to this angle, divided by the side that is opposite to A equals same thing on the other part. So the Y over B. And then this is called angle bisector theorem. Okay, we are going to use this one. So basically, whenever you do have a bisector, so the ratio of the side next to divided by opposite is same on both sides. So based on this, maybe, if you look at this triangle, ABQ, so this is a bisector, so 5 to 4 ratio, which means ratio of this 4 to XQ is equal to 5 to 8X. So if I call this is 5A, that means this is going to be 4A. Okay. And if I want to extend this guy, ABY and YBR, since this is also same bisector, and the ratio of BR is 8 to this guy is equal to 5 to this guy. So if I call this is 5B, that means this is going to be 8B. And if I extend this by BP, so ratio of 5 to AP is equal to 12 to PC. So now that will be 5, let's say C, that will be 12 C. We don't really need maybe this part, but I just did it that way. So we can see that angle bisector is actually helping in all of these regions, okay? So my focus is basically this point and this point, like, because, if I find the area of this triangle, AQR, and if I find the area of this triangle and subtract this from the larger one to get this region, which is kind of reasonable to do so. So let me go with the area of the AQR first. So AQR. So if you see that, this guy is a obtuse angle triangle because this is right angle. So this has to be acute. So this is obtuse. So if I take this segment as my base, the height for this side is actually this 5. So that is why I will just say 4 times 5 over 2 will be that area, but let me clear this part because I will have some more stuff going on there. So that means this is going to be 5, 4 over 2, which is 10. Okay, so that's good, at least for now. So we got the area of this region. I can find this as well if I want to, or I can find these two as well. But I just want to find this region so I can subtract from 10, okay? But another thing that we probably need to remember is the area and area relation with the triangles when you have same height. So what I mean by whenever you have like kind of reminder, whenever you have a bunch of triangles that share the same vertex, okay, so let's say this is A, B, C, D, let's say K. So if you take this point, common vertex for those triangles, and drop the altitude to the base, like side BC, BK, the height of ABC, height of AC, the height of ADK has to be same, right? So which is why the area ratio of those two triangles will be just the base ratio, because the height is the same. So the A times H over 2. If the height is same for all those triangles, the area ratio is just the side ratio. So which is why I'm going to use that idea in this triangle. But to do so, I like to connect this guy to this point because 5 to 8 ratio is useful, and then 5 to 4 ratio is also useful. So right now, what I want you to focus on is this triangle, AYQ. Okay, if you take this triangle, the Y is the common vertex, and the side is B, like 5A, this is 4A, which means if I want to say this is 5 times something as area, that means this is going to be 4 times something, okay? So let me write that. I'm going to call this region is 5A. Okay, one second. So if this is 5A as area, that means this guy will be 4A. Okay, so now using a similar reasoning, so I want you to now focus on this triangle. Maybe I should have used that color, but okay, so I'm gonna use now this guy. So if you take like this, this is my common vertex. If I drop the altitude from Q to AR like this way, so that height will be height for this triangle and this triangle. So the base ratio, which is 8 to 5, will be area of this guy to area of this guy. So let me write that part. So the 5 over 8 has to be equal to, again, this is 5, this is 8. That will be area of these two together, which is 9A, divided by area of the QRY. Okay, so area of the QRY. Okay, so if you do this, do cross multiplication, so you will get area of the QRY, which will be 72A over 5. So yeah, this region is 72 over 5A, and then we had 4 right here as well. So if you combine these two, which is what we want, right? But at the same time, we do know, actually, we could find this region a bit differently as well, but maybe I skipped that part. So, but you can do this anyway. So you got this region as 72A over 5, and then we have total these two as 9A. So if you add those two, so let me write maybe right here. So 9A plus 72A over 5, this is equal to 10 because that is what we got in total. So from here, if you want to find the A, so which is not going to be too bad, so multiply by 5, so that's 45A plus 72A is going to be 50, right? And then 70 and 110, so will be 117A is 150, just what, 50. So the A has to be 50 over 117. Okay, and then what we want is 4A plus this region. So this was a 72 over 5A. So if you add those two, which is what we are going to get in total, okay, 4A plus 72A over 5. And A is this guy. So if you combine those two, so you will actually get 920 over 117. I just skipped the middle step so you can do that to confirm. And this is my answer, which is not really simple as you see, but this is one thing you can. Okay, so let's continue with the second approach. So for now, I'm gonna use actually coordinates plane, okay? So because, I have a lot of points going on, and I can maybe write some of these like coordinates. So this point will be, if I take this line as my like y-axis, so this could be 0, 5. And if I take this as 0, 0, and then this is gonna be 4, 0, and this is gonna be 8, 0, right? So, and if you are familiar with the shoelace, so I just like to know these 4 points. If I know those 4 points, then I can find the area of this region, which is what I'm gonna try, okay? So we already know these 2 points, which is nice, and I just need to know these 2 guys. But, we were told this was 45 and 45, which means this line is, if I kind of extend this, is y equals x line, which is really nice. And if I want to find the equation of this line, so I can solve that system to get this point. And then if I want to find the equation of this guy, and then solve that equation to get this guy. So let's do this let's say t. So the slope of that line, at, is 5/4, which is negative, right? So negative 5, 4. So if I want to write the equation, so negative 5, 4x plus the y-intercept is 5, so that will be this. Okay, and then if I, this is the equation of at right here, and then y equals x was this line. So if I solve the system, so just plug y as x, so that should be x equals negative 5, 4x plus 5, multiply by 4 to get rid of that part fraction, so that is negative 5x plus 20, and 9x will be 20, x is 20/9. So we have something, 20/9, and then y is the same thing as well. So this point is 20/9, comma 20/9. So that is not really nice number, but that's okay. And now we already know this guy was x, so I'm gonna call that's x. And then this, it was called y. And I'll do the same thing. So let's do that as well. So this line has the slope of, let's say this is k, ak is 5/8, which will be just negative 5/8. And the slope will be negative 5/8 x, and the y-intercept is the same, which is gonna be this guy. And now if I wanna solve this one with y equals x, because that is my intersection of those two. So x equals negative 8x plus 5, multiply by 8, so that will be 8x equals minus 5x plus 40, so 13x is 40, that will be 40/13. And then y will be the same, so you will get 40/13 and 40/13 for your y point, okay? This is my y. And now we have this point, this point, this point, and this point. So now it's time to use the shoelace. So if you are not familiar with that, maybe it's good to take a look at some point. So I'm gonna just apply it. Usually whenever you see a 0, it's good to start with those points to make life a bit easier. So I will go with 4, 0 first. And then I'll go with maybe after x, which is 20/9 and 20/9. And then this is y is 40/13 and 40/13. And the last point is 8, 0. But we start with this guy. We just write this one more time. And the shoelace is, you just multiply the numbers sideways like this. Okay. And then you multiply the other way around as well. Okay. And then when you do this, the reason we choose zeros because they will give you twice zeros. That's good. And if you multiply this, you will get 800/913. So I'm gonna leave it for now. And if you multiply 8 by that, so that will be 320/13, and that is 0, and that's 80/9. And if you multiply this, that will be 800/9 times 13, and that is 0, that is 0. So what you do is you just add these guys, you add these guys. When you add these guys and these guys, you get two different sum. You take their absolute difference, okay? I'm gonna leave that part for you to try. Just add these, and find their difference, and take the absolute value and multiply that by 1/2. So you just do this 1/2 times the sum of these guys. So I'm gonna maybe write those 800 over, so that's 9117, right? Plus 320 over 13, and take the difference between the other part. So that is 80 over 9 plus 800 over 117. And if you take the difference, the positive difference, and then take the 1/2, you actually get the same result that we just got, okay? Which is 920 over 117. Again, I really needed to try this middle step that I skipped, and just get the same answer. And this is the second solution that I think come up with. But there's something else I'd like you to try if you are familiar with the mass point. So use the mass point and find the relation in terms of, the ratios of those sides, and see if you can go from there as well. So, and then I hope you can find something else if you try, okay? But anyway, so we at least 2 ways for now.